Welcome to DC Test Theory. In this short overview, we'll explore various DC parametric tests that are essential in semiconductor testing. We'll cover important aspects including input and output parameters, as well as critical power consumption measurements that ensure device quality and reliability. DC parametric tests encompass several crucial measurements that verify semiconductor device functionality. These include precision measurements using PMU, IDD leakage testing, and various input-output parameters. We'll examine key parameters such as VIH and VIL for input voltage levels, IIH and IIL for input currents, as well as VOH, VOL, IOH, and IOL for output characteristics. Additionally, we'll cover essential power consumption tests that ensure device efficiency. Let's begin with the open-short test, a fundamental procedure that uses PMU to detect manufacturing defects. The test setup involves applying a negative 100 microampere force current and measuring for a minus 0.65 volt threshold. This configuration allows us to effectively identify both open and short conditions, with specific pass-fail criteria for each case. When it comes to open-short testing, several common questions arise in practice. We'll address why devices typically have two diodes, explain the reasoning behind testing primarily the GND side diode, and discuss the implementation of FIMV mode. We'll also cover essential troubleshooting procedures for both open and short failure conditions. Moving on to the input leakage low test, or IIL, this measurement evaluates leakage current under specific conditions. The test utilizes PMU to force ground to individual pins, with a critical minus 10 milliamp threshold determining pass-fail status. This ensures proper input characteristics under low voltage conditions. The input leakage high test complements our low voltage testing by examining leakage current at high voltage levels. This test configuration applies a 5.5 volts force voltage with a plus 10 milliamp threshold serving as the failure criterion. This verification ensures proper device behavior under maximum voltage conditions. For output testing, we begin with the output voltage high test. This crucial measurement verifies proper output voltage levels under load conditions. The test applies a minus 5.2 milliamp force current, checking that the output maintains at least 2.4 volts, ensuring reliable high-level output operation. The output voltage low test is equally important, focusing on proper logic low output levels. Using an 8 milliamp force current, we verify that the output voltage remains below the maximum threshold of 0.4 volts, guaranteeing solid low-level output performance. The output short-circuit test is critical for verifying device protection capabilities. This test procedure involves forcing 0 volts and measuring current, with acceptable limits between minus 30 milliamps and minus 85 milliamps. This ensures the device can safely handle potential short-circuit conditions. Moving to power supply testing, the static ID test measures current consumption under static conditions. Using VDD max conditions, this test provides crucial information about the device's baseline power requirements. The gross VDD test serves as a broad check for major power consumption defects. This test requires careful attention to pin conditioning and applies specific pass-fail limits to identify significant power-related issues. Finally, the dynamic EDD test, which measures power consumption during actual device operation. This test combines pattern execution with precise current measurements to verify proper power consumption under dynamic conditions. Thanks for watching. See you on part 2.